Hi, I'm LVH, and I'd like to talk to you about icecap, which is a new project that I've started work on recently. It's an object capability system using URLs. So first of all, brief introduction, what are capabilities and why would you want them? So capabilities, you can think of them as abilities as objects. What does that mean? Well, they're first-class objects. So depending on what kind of system you're using, they can be object references, or as the case is the case in icecap, they can be URLs. But these are first-class things that you can pass around, reason about, store, etc. Um, it intrinsically is the ability to perform an action. So this thing and only this thing is how you gain the authority or get the authority to do something. In fact, and the way that's implemented is because that thing is exactly the way that you do it. It's not the key that opens up the door that lets you do it. It is the thing that lets you do it itself. That might sound a little bit confusing, but hopefully it'll become much clearer as these videos progress. For example, I can give you a URL that lets you create a server. And importantly, it does not let you store files, delete servers, create tickets, or anything else besides create a server. And a URL like that could look something like this. So the important part is the last part of that URL, which is a large random component, which means that you can't simply guess these URLs. So these are cryptographically random. Now, why would you want that? Well, there's a couple of reasons. By and large, the most important reason is security. Um, I'm going to go through that in more detail in the rest of this video. Also, ease of use, and to some extent, testability, because it tends to move side effects, especially important ones, out of your program. But I would say that the most important benefit is security, and the second most important benefit is ease of use by a large margin. This lets you write code according to the least authority principle, which simply put just means don't give stuff more power than it needs, which sounds extremely obvious when you put it that way, but it turns out that by and large, that's not how we actually write software. And a good simple analogy just to get you accustomed to the idea could be a valet key. Because the valet needs to be able to drive the car to the parking lot and back. Does not need to be able to drive the car cross country at 100 miles per hour. There's a number of other things that valet keys don't let you do, like glove compartment, trunk, etc. But the point is that you want to give some limited authority to someone else. So this valet key gives that person that specific authority, and it is a simple example of a capability. Another analogy is house keys. So let's say that you have a house with some dangerous and or valuable goods, stuff like money, jewelry, chemicals, guns, then I would certainly hope that you protect those things separately. For example, if you have money and jewelry, you can put them in a safe. If you have chemicals, you can put them in a shed and then put a separate lock and key on the shed. And if you have guns, like a gun locker, right? So the idea is that you don't just have a house key, and then as soon as you're in the house, then suddenly you have access to everything because that's insecure. So you want more specific authorities. Now these key analogies are a good start to just give you an idea of how this makes sense coming from a real world perspective. But they are not the whole story because capabilities give you significantly more capabilities. Sorry for that pun, that was actually completely unintentional. So capabilities let you do a lot more things, and they're actually significantly easier to use than your average key. So, but it's a good start nonetheless. So capability systems, as far as I've seen and as far as I'm concerned, this partially might be an opinion, but I consider them to be the state of the art for authorization. And I will briefly go through some of their benefits in order to illustrate why I believe that's the case. So first of all, they're not equivalent to ACLs. They're significantly better than ACLs in several ways. For example, they're much more expressive. It's much easier to express very, very specific goals in a capability, which you generally cannot do in an ACL. They're much easier to use, and they provide much stronger guarantees. So, for example, one of the ways that they are more expressive than ACLs is in granularity, because ACLs make several assumptions. For example, an ACL assumes that all actors are known ahead of time, or at least classes of actors are known ahead of time. For example, you know that you're going to give access to user accounts, right? But that means that you're already limited to only things that exist in this universe of user accounts. If you're a piece of software that has ever had to create a user account pretending that it's a human for a program that's only intended to be used by humans just so it could get some kind of authority, or so it could be named in the system, then you've seen this problem. It also assumes that all actions are known ahead of time, which might sound plausible, except when you start thinking that it also assumes that all actions are atomic. So just because um, we can say, for example, we know that the create server action is known ahead of time. That's fine. But that also assumes that all of these specific kinds of server creation are going to be known ahead of time, and that there's no subdivision. That create server is create server is create server. They're all the same thing. We can all paint them in the same flag, and there's no difference between there's no interesting difference between any of these calls. Um, so, for example, a granularity example with a really simple ACL, you can have a server management role, which allows you to create, retrieve, update, delete servers, right? Very simple. A more sophisticated granular ACL might say that you have create server access. Okay, so then you're separating the server creation from listing servers, or server creation from deleting servers, something like that. That's good. That's an improvement. That's definitely better than a generic server management role. But think about what you could do with a capability. You could say, I want a capability that lets you create servers of flavor F. That's a fancy way of saying servers with this much memory, this many cores, yada yada yada, and with the base image I. Right, so you sort of get dependent typing. Same way that you have dependent typing in programming languages, you can get dependent typing for your access control. And I mean, this is extremely simple to do with capability, and perhaps more importantly, it's pretty much exactly as simple as it is to not do it. Whereas with an ACL, generally this is not possible. Another way that capabilities are better is composability. Suppose that you have something that you want to delegate to A, it's an actor, and it needs to do X and then Y. So X and Y are separate actions, and it needs to do them in that order. And it needs to wait until X is complete and then do Y. That sounds pretty simple. And with ACLs, what does that look like? Well, first of all, you have the problem, which is really a granularity problem, that I talked about before, that A needs to be a separate named actor that is known ahead of time, which can be problematic, but let's just assume that we solve that problem. And then we give A access to X and Y, right? This sounds kind of obvious. If A needs to do X and then Y, then A needs to be able to do X and needs to be able to do Y. Except we've now actually already given A, almost without thinking about it, more authority than it really needs, because there are plenty of actions that we've just allowed. For example, we've allowed A to do X but not Y. We've allowed A to do X and then X again for some reason. And these are, obviously that's not what A is supposed to do, but the point is that our access control system happily allows it to do that. And also, and this is again really a granularity problem, we've let A do X and Y, but because X and Y are specific actions, they almost certainly don't have an exact specific access control category for them. So in reality, not only have we allowed X and Y, or in any combination, but we've probably also allowed Z, and we're probably also allowed Aleph, and we're probably also allowed Han, which I'm told is the Han character for explosions. So yes, we've now allowed explosions, which is a bad thing. On the other hand, you have capabilities where you can actually say, I want a capability that only lets them do X and then Y. And it does not let them do X, it does not let them do Y, it does not let them do X but not Y. It only lets them do X and then Y, and that is the only thing you can do with that capability. And you can even do that, and this is where composability comes in, you can do that using existing X and Y capabilities. So if I have these fairly powerful capabilities, quote unquote, then it's very easy for me to create sort of sub parts of it that I can then delegate to other people securely. The user experience is better than ACLs because you can actually describe the action that you want. You don't have to worry about the thing that you want, what that translates to on an ACL level. And also on the server side, or on the, obviously a lot of these things are servers and clients at the same time, but you don't have to, whatever it is that's responding to your request, you don't have to implement ACLs. You don't have to worry about what this role actually means. There is no option for you to implement that and, for example, get it wrong. This is like an entire class of security bugs that are just magically just excluded, that cannot happen. I mean, there's a lot of confused deputy problems that can no longer happen simply because you're allowed to be so incredibly specific about which capabilities you want to provide to other pieces of software. And UX is incredibly important. I'm reminded of an analogy with crypto. Obviously, this is not a pure crypto problem, but we have strong crypto. The problem is not how strong our crypto primitives are. The problem is that we can't get people to use them. And the issue there is that if you have poor UX, that becomes a security problem. If it's hard to use your ACL correctly, then that doesn't mean people are going to still use your ACL correctly. No, it means that people are going to get it wrong, and it means that there's going to be security issues. And it's very easy to blame it on the person who actually made the mistake, but I don't really think that's fair when we're giving them tools that make it virtually impossible for them to do the right thing. We're essentially setting them up to fail. Finally, since I started talking about security, I think the security aspects of capability systems are much, much better than those of ACLs because the backing for saying that you are going to do the specific action and no other actions is based on cryptography, not pinky swears. We're not, you're not promising pinky swearing that this piece of software is not only going to check the ACLs, it's going to apply the ACLs correctly, and there are no options for it to be confused, right? So that's a pretty big stretch. Whereas with capabilities, you can't guess the URL because there are too many bits in the URL. You can't really, you can't hack the database and then decrypt all of those things because they're encrypted using very, very strong crypto. So the guarantees that you get that this system is going to work is cryptographic, not hope that some software was written correctly and doesn't have bugs. And this also lets us give a very, very strong guarantee where, from simply almost an information theoretical point of view, that even if all of our servers are owned, there is zero data compromise, unless you have attackers that have literally several universes of computer at their disposal, in which case you have bigger problems. But simply because we don't store the capabilities, and you need the capability in order to even decrypt, and actually in the case of icecap, even figure out where in the database this thing is stored. Therefore, we can guarantee that even if all of our data is lost, as long as they don't have the capabilities, which we don't store, then there is zero user data that's been lost. So anyway, I know that was a lot of stuff. I hope that that I at least got you a little bit excited and enthused about capability systems. I invite you to take a look at icecap, and I look forward to your comments.